let us do a problem based on Faraday lenz's law. Refer the circuit shown in figure 1. The magnetic flux density B is equal to 10T Tesla is normally into the page. It is into the page. Therefore, you are seeing the back of the arrow or the feather of the arrow. Find the voltages V1 and V2. Solution. The flux penetrating the loop is phi is equal to surface integral vector B dot ds. Since vector B is normal to the surface S, B dot ds is equal to B into ds. Dot product becomes simple product. Correct? Since vector B is normally since vector B is normal to the surface S, vector B dot ds is equal to B into ds. Hence, phi is equal to surface integral B into ds. B is a function of t only. That means B is independent of space coordinates like x, y, z. Hence, B can be taken out of the integral. I am going to write now, since B is independent of space coordinates. Space coordinates means in Cartesian coordinate system x, y, z, cylindrical coordinate system rho, phi, z, spherical coordinate system r, theta, phi is independent of space coordinate. B can be taken outside the integral. Thus, phi is equal to B into surface integral ds. What is B? B is given as 10T. What is integral ds? Area of this rectangular loop, which is what? 4 into 2. 4 into 2 means 8. 8 into 10 is 80. 80T Webers. This is the flux penetrating this rectangular surface, having the dimension 4 meters by 2 meters. So this is phi. So what is Vf now? What is the magnitude of the induced EMF? The magnitude of the induced EMF is Vf is equal to d phi by dt equals d by dt operating on 80T. So you get 80 volts. The polarities of Vf are marked so that the current I circulated by it produces a magnetic field vector B induced that opposes the original field vector B. So I mark the polarities now. Now what should be the direction of, I'll write the figure here. This is 200 ohms. This is 100 ohms. This is vector B. Direction of vector B induced must be opposite to that of vector B. So this is vector B induced. vector B induced is coming out of the board. According to right hand rule, thumb indicates the direction of vector B induced and the fingers indicate the direction which current has to flow. The current has to flow in the anti-clockwise direction. The current has to flow in the anti-clockwise direction. Therefore, this is how the polarities of VF are marked. Polarities of VF are marked. Now this voltage is V1 and this voltage is V2. What is current I? Current I is equal to VF divided by 200 plus 100 is equal to 80 divided by 300 amperes. Hence, V1 is equal to 200 into I equals 200 into 80 divided by 300 volts, and V2 is equal to 100 into I equals 100 into 80 divided by 300 volts. This is how the problem is tackled. So first thing is you have to calculate what is the flux penetrating the surface bounded by the rectangular contour. Then apply the formula Vf is equal to d phi by dt. Then you have to mark the polarities of Vf. To mark the polarities of Vf, this is the guideline. The polarities of Vf are marked so that the current I circulated by it produces a magnetic field vector B induced that opposes the original field. The original field is into the board. So induced field should be out of the board. So thumb indicates the direction of vector B induced and the fingers indicate the circulated current. Since my fingers are closing in the anti-clockwise direction, the current has to flow in the anti-clockwise direction. That fixes the polarities of Vf. Once you know Vf polarities, you find I. I is equal to what? Vf divided by 200 plus 100. Then V1 is equal to 200 into Ohm's law. V2 is equal to 100 into I. V1 plus V2, if you add V1 and V2, you must get Vf. That verifies the result. Thank you. Okay. The next problem. Refer the circuit shown in figure 1. Find the voltage V0 in the circuit. The magnetic field is into the board and is perpendicular to the board. The inner loop is the inner rectangular loop. It has dimension 40 centimeter by 10 centimeter. The outer loop has dimension 60 centimeters by 20 centimeters. Solution. The flux penetrating the inner loop is phi is equal to phi1 is equal to surface integral vector B dot ds. The surface I will call S1. See, B is perpendicular to the surface bounded by this rectangular contour or to the rectangular loop. Therefore, it becomes B into D dot ds becomes B into ds. Now, B can be taken outside the integral because B is independent of the coordinates x, y and z. Therefore, this becomes B into integral ds over the surface S1. S1 is the surface area of the inner loop. So what is B? B is what? B is what? 5t. And what is the area of this inner rectangular loop? 0.4 meters into 0.1 meters. So this is nothing but 5 into 0.04t. 0.5 into 0.04t, which is 0.2t Webbers. The flux penetrating the outer loop is phi 2 is equal to surface integral B dot ds. The surface will be called now S2. Since vector B is perpendicular to the surface bounded by the outer rectangular loop, this dot product becomes simple product. So it becomes B into ds over the surface S2. Here S2 refers to the surface bounded by the outer loop. B can be taken out of this surface integration because B is a pure function of t only. In other words, it is independent of the space coordinates x, y and z. So this becomes B into surface integral ds. So this B is what? B is 5t into, what is the area of the outer rectangular loop? 0.6 into 0.2. So this is 5 into 1.2 t. So 5 into 1.2 t is 60 Webbers. So this is how we find the flux penetrating. 6 into 0.2 is 0.12. Sorry, 0.12. 0.12 means 0.60. The flux penetrating the outer and inner loops we have found. Next is the EMF induced. The magnitude of the EMF induced in the inner loop is Vf1 is equal to d phi 1 by dt. So d phi 1 by dt means you get d by dt operating on 0.2 t. So you get 0.2 volts. The magnitude of the EMF induced in the outer loop is Vf2 is equal to d phi 2 by dt is equal to d by dt operating on phi 2. Phi 2 is what? 0.6 t. So you get 0.6 volts. So what I have done to begin with is, we have found what is the flux penetrating the inner rectangular loop. Then we have found what is the flux penetrating the outer rectangular loop. Then we have found the magnitude of the induced EMF using Faraday Lenz's law. Vf1 is equal to d phi 1 by dt. Phi 1 is equal to 0.2 t. Then we have found Vf2, magnitude of the EMF induced in the outer loop, which is d phi 2 by dt. d by dt operating on 0.60, that gives you 0.6 volts. The next step is to insert the voltages Vf1 and Vf2. If you see, the next step is to insert the voltages Vf1 and Vf2. So that I am going to do now. So this is the direction of B. This should be the direction of B induced. B induced is coming out of the board. Thumb should be in the direction of B induced and fingers must indicate the direction of the induced current. So if thumb is coming out, my fingers are closing in the anti-clockwise direction. Therefore the current I1 should be in the anti-clockwise direction. Hence the polarities of Vf1 should be like this. Similarly, the polarities of Vf2. The polarities of Vf1 and Vf2 are as shown in figure number 2. What I have done? Vector original magnetic field is into the board. The induced magnetic field should be out of the board. Then apply right hand rule to find the direction of the current I1. Thumb indicates the direction of B induced. Fingers are closing in which direction? Fingers are closing in the anti-clockwise direction. Therefore, current I1 has to circulate in the anti-clockwise direction. For current I1 to be circulated in the anti-clockwise direction, the polarities of Vf1 should be as indicated in this figure. Similarly, the polarities of Vf2 are marked. Current I2 cannot flow because there is an open circuit over here. Okay. The polarities of Vf1 and Vf2 are as shown in figure number 2. What is I1? I1 is equal to VF1 divided by 100 plus 200. What is VF1? VF1 is 0.2. 0.2 divided by 300. So many amperes. Applying KVL to the outer loop in the anti-clockwise direction. In the anti-clockwise direction gives, this is the current I1. So start from here, 200 into I1 minus VF2 because we are moving from minus to plus V0 equal to 0. This implies V0 is equal to VF2 minus 200 I1. VF2 is what? VF2 is 0.6 minus 200 into 0.2 by 300. So this gives you the answer. 0.467 volts. This gives you the answer 0.467 volts. This is how this problem is tackled. Very commonly asked problem in the examination. We shall go to next problem. The next problem is, find the voltage V0. Find the voltage V0 for the circuit shown in figure 1. For the circuit shown in figure 1, 100 ohms, 100 ohms, and this is plus minus V0. The dimensions I will write down now. This is 0.5 meters. This is 0.3 meters. And this is 0.2 meters. 0.2 meters. Vector B is coming out of the page or coming out of the board, and B is given by the relation 10 sine 2 pi into 60t Tesla. This is the expression for vector B, or magnetic flux density, magnitude of vector B, 10 sine 2 pi into 60t Tesla. There are two loops now. This loop is a rectangular loop called the left loop, having the dimension 0.2 meters by 0.5 meters. There is one more rectangular loop on the right side called right loop, whose dimension is 0.2 meters by 0.3 meters. We have to find the voltage V0. So same technique we will use. Solution: the flux penetrating the left loop is phi 1 is equal to surface integral vector B dot ds. This is nothing but surface integral B into ds. Dot product is dispensed off because vector B is normal to the surface bounded by this inner rectangular loop. B is taken out because B is independent of x, y and z. Now what is B? B is 10 sine 120 pi t And what is the area of this inner rectangular loop? 0.2 into 0.5. So this becomes 10 into 0.2 into 0.5 is 0.1 into sine 120 pi t. So this 0.1, 10 into 0.1 is 1. So you get sine 120 pi t, so many Webers. The flux penetrating the outer loop is phi 2 is equal to surface integral vector b dot ds. Here S2 refers to the area bounded by this by the right rectangular loop. S2 refers to the area bounded by this right rectangular loop. So what is b? Is nothing but b into surface integral ds. What is b? b is 10 sine 120 pi t. And what is surface integral ds? 0.2 into 0.3. 0.2 into 0.3 is what? 0.06. So this is 10 into 0.06 into sine 120 pi t. So 10 into 0.06 means it is 0.6 into sine 120 pi t Webers. This is how phi 1 and phi 2 are found. Next step is to find V1 and V2. Vf1 is equal to d phi 1 by dt. So differentiate this with respect to t. So what you get? Sin, if you differentiate, you get cos 120 pi t multiplied by 120 pi. So many volts. What is Vf2? Vf2 is what? d phi 2 by dt. Differentiate this with respect to t. So it is 0.6 into 120 pi cos of 120 pi t volts. The figure, the circuit diagram after inserting the voltages Vf1 and Vf2 is as shown in figure number 2. Now this is the this I call figure number 2. You have to write a separate figure number 2. This is the direction of original magnetic field. This has to be the direction of induced magnetic field. Again apply right hand rule. Thumb should be in the direction of B induced. This is the thumb induced. The current, my fingers are closing in which direction? Clockwise. Therefore the current I1 should flow clockwise. Therefore what should be the polarity of Vf1? This should be plus, this should be minus. This current is again I1. So this is the current I1 circulated by Vf1. This is Vf2. Vf2 does not circulate a current because of the open circuit over here. So what is Vf1? What is Vf1? We have calculated. What is Vf2? We have calculated. What is current I1? Current I1 is Vf1 divided by 100 plus 100. That means 0.6 into 120 pi divided by 200 into cos 120 pi t. So many amperes. Applying KVL to the loop on the right. The loop on the right gives, start from here, plus to minus, plus or start from here, 100 I1, we are going in the anti-clockwise direction, 100 I1 minus V0 plus Vf2 equal to 0. This implies V0 is equal to Vf2 plus 100 I1. Substitute what is VF2? VF2 is 0.6 into 120 pi cos of 120 pi t plus 100 I1. 100 into what is I1? I1 is 0.6 into 120 pi divided by 200 into cos 120 pi t. Cos 120 pi t. So many volts. This is how the problem is tackled. Simplify and keep the answer. Thank you. Next problem. The circuit shown in the figure is located in a magnetic field of vector B, magnetic field of flux density, magnetic field of flux density. Vector B equals 3 cos 5 pi 10 to the power 7 into t minus 2 pi by 3 into x az cap. Please note that vector B is a function of time and x. X means space coordinate. In the previous problems, vector B was a pure function of t only. It's a function of t and x. So I am going to solve the problem in this manner. The flux penetrating the loop is phi is equal to surface integral vector B dot ds. Vector B is perpendicular to the loop. Therefore, dot product becomes what? See here, vector B is what? Bz into az cap. What is vector ds? Dsz into az cap. Az cap dot az cap becomes 1. So bz into dsz. That means the dot product becomes simple product of the magnitudes of vector B and vector ds. So what is this dsz? Dsz is nothing but dx into dy. So this implies phi is equal to, please note, surface integral is a double integral. Bz cannot be taken out of the surface integral because B contains x. So what is Bz? Bz is 3 cos 5 pi into 10 to the power 7 into t minus 2 pi by 3 into x dx dy. X varies from 0 to 0.6 here, 0 to 0.6. Y varies from 0 to 0.2. So if you integrate, so here 3 is a constant. This is micro Tesla. Therefore, the factor 10 to the power minus 6 I keep out here. So this 3 I will take out. 3 into 10 to the power minus 6. dy, if I integrate, I get y, put limits, I get 0.2. Next, you have to integrate with respect to x. Cos, if you integrate, you get sine 5 pi 10 to the power 7 into t minus 2 pi by 3 into x divided by minus 2 pi by 3. Limits for x from 0 to 0.2. 0 to 0.6 or 0 to 0.6. So this implies phi is equal to 3 into 10 to the power minus 6 into 0.2 into minus 3 by 2 pi. I'll put the upper limit now, upper limit for x. So I get sine 5 pi into 10 to the power 7 into t. You put x is equal to 0.6. So you get minus 2 pi by 3 into 0.6 minus sine, then you put x equal to 0. You get 5 pi into 10 to the power 7 into t. So this is the expression for phi. Then what is Vf? Vf is equal to magnitude of the induced EMF. Magnitude of the induced EMF. What is the magnitude of the induced EMF? d phi by dt. So this expression you differentiate with respect to t. How do you mark the polarities of Vf? How do you mark the polarities of BF? This is the direction of vector B induced. It is into the board. So my fingers are closing in which direction? Clockwise. Therefore current is flowing in clockwise direction. If current has to flow in the clockwise direction, correct, what should be the polarity of VF? This should be the polarity of VF. Correct, this is figure number 2 after inserting VF. So please find VF. This is left as an homework for you. You know what is phi? Differentiate phi with respect to get the expression. Then what is current I? Current I is equal to VF divided by R. So many amperes. So this problem has to be tackled in this manner. Here you have to be very careful. B is a function of t and x. Therefore, B cannot be taken outside the surface integral. With this, we end this problem. Thank you. So all these calculations you do on your own, not difficult. You have to differentiate sine theta, sine x, sine ax. If you differentiate, what you get? A times cos ax. Very simple. Then VF you divide by R. The value of R is given the problem as 100 ohms. This is the end of this problem. Thank you. Next topic. Faraday's law in point form. I take an open surface. This is an open surface S bounded by contour C. I take a small elemental area ds. This unit vector A and cap perpendicular to the elemental area ds. In other words, vector ds has got magnitude dx, direction given by A and cap. The Faraday's law is contour integral C vector E dot dl is equal to minus d by dt surface integral vector B dot ds. This implies contour integral C vector E dot dl is equal to minus surface integral dou B by dou t dot ds plus contour integral C vector u cross B dot dl, where vector u is the velocity, with which contour C is changing its position or shape with respect to time. This I'll call equation 2. This I'll call equation 1. If contour C is stationary. Contour C is stationary means in the bracket I'll write vector u is equal to 0. Then equation 2 reduces to contour integral C vector E dot dl is equal to minus surface integral vector dou B by dou t dot ds. This I call equation 3. This contour integral is converted into an open surface integral by using Stokes theorem. See the importance of Stokes theorem. Applying Stokes theorem to the contour integral on the LHS left hand side of equation 3 gives open surface integral del cross h dot ds is equal to minus open surface integral vector dou b by dou t dot ds. Since the above equation is true for any surface yes, in the limiting case we get this is del cross E. In the limiting case we get del cross E is equal to minus dou B by dou T. This is equation number 4. Equation 4 is called as Faraday-Lenz's law in point form and is computationally more efficient than Faraday's law in the integral form. Also, equation 4 is known as Maxwell's equation in point form for time-varying fields as derived from Faraday-Lenz's law. This equation is very important in wave propagation. Let me write. Equation 4 is known as ME is the short form for Maxwell's equation, known as Maxwell's equation derived from Faraday's law in point form for time varying fields. Equation 4 is known as Maxwell's equation derived from Faraday-Lenz's law in point form for time varying fields. Also, equation 4 is known as Faraday-Lenz's law in point form and is computationally more efficient than the corresponding integral form. Very, very important topic. Asked for 6 marks in the examination. In almost all question paper this topic appears. So practice this and write it properly in the examination. Thank you. A two-dimensional electric field is given by vector E is equal to 2x cube into ax cap plus 4x to the power 4 into ay cap volts per meter. Show that this field cannot arise from a static distribution of charge. Very important problem. Solution. Let us first find del cross E. The problem is given in Cartesian coordinate system. Therefore, del cross E is equal to determinant ax cap, ay cap, az cap, dou by dou x, dou by dou y, dou by dou z, ex, ey, ez. Since vector E is a function of x only, dou by dou y equals 0 and dou by dou z is equal to 0. Also, what is Ex? Ex is equal to 2x cube, and what is Ey? Ey is equal to 4x to the power 4. Hence, Hence del cross E is equal to determinant Ax cap, Ay cap, Az cap. Dou by dou y is 0, dou by dou z is 0, Ex is non-zero, Ey is non-zero, Ez is 0. Ez is 0. Expand this determinant. If you expand this determinant, Ax cap, this into this one, this into this 0. Ay cap also won't give any coefficients, only Az cap will give. Az cap into dou Ey by dou x. So if you differentiate Ey with respect to x, so what you get? You get 16x cube into Az cap. So correct Az cap. Since del cross E not equal to 0, it implies the charge distribution is not static. It implies that the charge distribution is not unique. If the charge distribution is static, charge distribution is not static. If it were static, del cross E would have been equal to 0. Because for a static distribution, we have got the conservative property, contour integral vector E dot dl equal to 0. If you apply Stokes theorem, you get del cross E dot ds equal to 0. In the limiting case, you get del cross E is equal to 0. Del cross E is equal to 0 is valid only for static distribution of charges. Since del cross E here is 16x cubed into Az cap, it implies del cross E not equal to 0. Therefore, charge distribution is not static. Thank you. Next problem. If vector E is equal to Em sin alpha x sin omega t minus beta z Ay cap volts per meter in free space, find vector H. Solution. Recall del cross E is equal to minus dou B by dou T. This implies del cross E is equal to minus dou by dou T. What is vector B? Vector B is mu naught into vector H. This implies vector dou H by dou T. Vector dou H by dou T. This minus sign and mu naught I transfer to left side equals minus 1 over mu naught into del cross E. In Cartesian coordinate system, what is del cross E? Determinant Ax cap, Ay cap, Az cap. Dou by dou x, dou by dou y, dou by dou z, Ex, Ey, Ez. Since vector E is a function of x and z only, it implies dou by dou y equal to 0. Also, Ex is equal to 0, Ey is equal to Em into sin alpha x into sin omega t minus beta z, and Ez is equal to 0. Therefore, Ex is 0 because there is no unit vector Ax cap associated with vector E. Ez equal to 0 because there is no unit vector Az cap associated with vector E. Coefficient of Ay cap is Ey. And therefore, vector dou H by dou T is equal to minus 1 over mu naught determinant Ax cap, Ay cap, Az cap, dou by dou x 0, dou by dou z 0, Ey 0. So this is nothing but minus 1 over mu naught into dou Ey by dou x into Ax cap. Ax cap into dou Eu by dou x. This into this is, sorry, I made a mistake. Ax cap into this into this is 0, minus this into this, so into minus dou Ey by dou z. Ax cap, this into this is 0, minus dou Ey by dou z. Next, there is no coefficient of with respect to Ay cap, plus Az cap into this into this, minus this into this, dou Ey by dou x. So this is minus 1 over mu naught into minus, you differentiate Ey with respect to z. You differentiate Ey with respect to z. So you get Em sin alpha x. Sin, if you differentiate, sin omega t minus beta z, if you differentiate, you get cos omega t minus beta z into minus beta into unit vector Ax cap. Now differentiate Ey with respect to x. So this is plus Em sin omega t minus beta z is a constant. Sin alpha x, if you differentiate with respect to x, you get cos alpha x into alpha, whole thing multiplied by Az cap. Correct? Now next what I will do is, this implies vector dou h by dou t is equal to minus into minus plus, plus into minus is minus Em divided by mu naught into sin alpha x into beta, right? Em into beta by mu naught sin alpha x into cos omega t minus beta z into Ax cap. Here plus into minus is minus plus into minus is minus Em into alpha divided by mu naught into cos alpha x into sin omega t minus beta z into Az cap. Integrating with respect to t gives vector h is equal to minus Em into beta by mu naught sin alpha x. If you differentiate, if you integrate cos, what you get? You get sin omega t minus beta z divided by omega into Ax cap minus Em into alpha cos alpha x divided by mu naught. If you integrate sin omega t minus beta z with respect to t, you get minus cos omega t minus beta z divided by omega whole thing multiplied by az cap. So this gives minus em into beta divided by omega into mu naught sin alpha x sin omega t minus beta z into ax cap minus into minus plus em into alpha divided by omega into mu naught cos alpha x into cos omega t minus beta z into az cap. Unit of vector h is amperes per meter. This is the end of the solution. Thank you.